Hi everybody. Today we're going to start talking about the subject of electric charge. So our objectives for today are to understand why objects can be charged and then to be able to calculate the charge on an object. So first of all, where does charge come from? Well, remember that all matter is made up of atoms and all atoms are made up of subatomic particles. I'm going to ask you to remember some chemistry here. Those subatomic particles are protons, which are positively charged, neutrons, which have no charge, and electrons, which are negatively charged. The protons and the neutrons are found in the nucleus of every atom, and the electrons are found outside the nucleus, orbiting in those energy levels. Now, you might also remember that most atoms have equal number of electrons and protons, so they balance each other as far as being positively charged and negatively charged, and most atoms are electrically neutral. But if an atom gains or loses an electron, it becomes charged, and that charged atom is called an ion. Now, negatively charged ions have more electrons than protons, meaning that they have gained some electrons from another atom. And positively charged ions have fewer electrons than protons, meaning they have more protons than electrons. But that happens because they have given away some of their electrons to another atom. How do we measure charge? Well, because the amount of electric charge on an object depends just on how many excess electrons or protons it has, meaning the difference between the two or the imbalance in protons and electrons, the net charge on an object is always going to be in exact multiples of the charge of an electron or the charge of a proton, because you can't have half of an electron or half of a proton in an atom. That property of charge occurring in only multiples of a specific thing, or number in this case, means it's quantized. It only happens in discrete multiples or fixed numbers. So when an object is charged, its charge is always a multiple of what we call a fundamental unit of charge. The charge on a proton or the charge on an electron. And we represent that fundamental unit of charge with the letter E. This E is known as that elementary charge. So a single electron has a charge of negative E, and a single proton has a charge of positive E. So what's E? Well, first of all, let's look at how we can measure E and what type of unit it comes in. The metric system unit for charge is called the coulomb. It's represented with an uppercase C. Both an electron and a proton, we know, have the same charge value, but they're opposite. So E in coulombs is equal to 1.6 times 10 to the 19th coulombs. It's a very small number. A coulomb is a very large unit of charge. So as a result, you're going to find our scientific notation sticks around for a little bit longer, and we end up with some of those prefixes from the metric system that represents small numbers, milli, micro, nano. So we have to get familiar with those. But so let's look at an electron then. Since it has that fundamental unit of charge E, it has a charge of 1.6 times 10 to the negative 19th coulombs, but it's a negative charge. A proton has that fundamental charge of E, 1.6 times 10 to the negative 19th coulombs, but it's a positive charge. When we start talking about the net charge, or the sum of all the charge on the object because of excess electrons or excess protons, we use a small q to represent charge. Okay, let's look at an example just to make sure everything's making sense. We have an object that has an excess of 6.0 times 10 to the 6 electrons, and we want to know what its net charge is. So, net charge is represented by that lowercase q, and the net charge is going to be caused by that 6.0 times 10 to the 6 electrons. All right. And And we have to remember that every electron has that charge of negative 1.6 times 10 to the negative 19th coulombs, which means that our net charge on our object would be 9.6 times 10 to the minus 13th coulombs negative. Don't forget that, because we're talking about excess electrons. Okay, here we have an alpha particle, has 2 protons and 2 neutrons. We want to know what is the net charge of an alpha particle. We don't have any electrons here, so as a result we have an excess of protons and we have an excess of 2 protons. All right, so 2 protons, and same thing here. We would remember that each proton has a charge of 1.6 times 10 to the negative 19th coulombs. And just make sure you remember that's a positive charge. My 1 proton, my 1 proton. So essentially Q here would be equal to 3.2 times 10 to the negative 19th coulombs. And again, it would be positive. Okay, so that about wraps up charge. Thanks.